Hello guys, today we're going to be talking about direct variation. So our two different main ideas is we're going to write and graph direct variation equations, and we're going to solve problems involving direct variation, so two different things. So what is a direct variation? Well, here's our key concept. Direct variations are any equations in the form of y equals kx. There's no pluses, no minuses. Do notice that k cannot be 0, so it's like y equals 2x, or y equals negative 3x, or y equals 3/4 x. Okay, those are all examples that can be used. Just it can't be y equals 0. The graph always passes through the origin. We'll talk about graphs that don't pass through the origin next week. But right now, that is what we're going to do. If the slope is positive, it is an uphill line. We talked about that with slope. And if the slope is negative, it's a downhill line. And it looks something like this. Notice again, it's going through the origin here on both of these. So, name the constant of variation for this equation. Then find the slope of the line that passes through the pair of points. The constant of variation and the slope, they're the exact same thing. So you don't have to do both of those. So how do we find slope? Well, that's our y2 minus y1 over x2 minus x1. So we're still going to do those. So we have 2 points. We have 1, 2, and 0, 0. So 0, 0 is our first point, and our 2 is 1, 2. So it's 2 minus 0 and 1 minus 0, or just 2. And we should notice that the line is positive, so we should get a positive answer. So our answer is 2. So the constant of variation is 2, and the slope is 2. It's the same for both. Let's try another one. Notice this is downhill, so we should get a negative answer. So y2 minus y1, x2 minus x1. Again, we have 0, 0 as our 1s, and 1, negative 4 now as our 2. So negative 4 minus 0 is just negative 4, and 1 minus 0 is, of course, just 1. So we have an answer of negative 4. If you go ahead and put the origin point as your 1s, it's going to become very easy because you're going to be subtracting 0 each time. If you put them first, it makes it a little more difficult, but you will get the same answer nonetheless. All right, another one. Here we have the point 1, 4. Again, it's positive, so we should get a positive answer. So we have 0, 0, and 1, 4. So 4 minus 0 and 1 minus 0, which is 4 over 1, or just 4. So, of course, our answer is 4 yet again. All right, so how can we graph this? Y equals, in this case, 1x. Notice we didn't put the 1 there. It could have been a 2 or a 3, and they would have put it there. But this is just a 1 here. So write the slope as a ratio. 1 has to be written as 1 over 1. So we're going to rise 1 and run 1. So we're going to start at our origin, because that's all direct variation problems start at the origin. And then we're going to go from there. We're going to go up 1 and over 1. So up 1 and over 1. And over is always to the right. So we go up 1 and then over 1. And then we can go ahead and keep going up 1 and over 1, up 1 and over 1. And those gives us all the different points. And we make a nice line such as this. And it is a positive 1, so we should get a positive graph. So what about this one? Negative 3/2. So it's negative, so we should get a line that goes down. So we're going to write the slope as negative 3/2. We write it as negative 3 over 2. So we're going to go down 3 and then over 2. So here's our graph, 0, 0. And now we're going to go down 3 spots and then over 2. So down 3 and then over 2. So down 3 and over 2. That's my next dot. And now we can create a line there. And that line is going down, just like our negative tells us it would. So what about 2x? 2x is a positive 1. So we know right away that a and d are not possibilities. So we start at the origin, and 2 can be written as 2 over 1. So we're going to go up 2 and over 1. Well, this one doesn't do that. What about this one? Up 2 and over 1. Yeah, that does. So my answer has to be B. All right, so that's what a direct variation is. Now let's talk about a direct variation problem. Oh, one more graph. Negative 2/3. So A is out and B is out because those are both positive. So negative 2/3, we go down 2 and over 3. So So if I go down 2 and over 3, I'm over at this point here. This one's not it. Down 2 and over 3, it's got to be D. All right, now let's deal with the direct variation problems. How do we do that? We have some steps here. So I have 2 different columns to go ahead and do this. Our first step is just y equals kx. And then we're going to plug in our first ordered pair into the x and y, into the 2 x's and y's here. Obviously, that leaves us just k, so we're going to solve for k by dividing by that x. We're going to divide that x over. Then we're going to rewrite it as y equals whatever that number is, times x. We're going to plug in whatever value they want us to give to do, and then we're going to solve the missing variable. So let me show you how this works. So here's our equation. Suppose y varies directly to x, and y equals 9 when x is negative 3. So that's my first ordered pair that I was talking about here. When it says plug in the first ordered pair, that's this. They're going to tell us an ordered pair, negative 3 and 9. Then this part here is for the second part over here. That's when we're going to plug in the given value. So there's 2 different areas. We're going to do the first one first. We're going to do this left side of our steps here first, get k. So we're going to kind of get an answer, but we're going to put that answer back in to get the final answer. So the first order pair is going to give us that k. So we start off with y equals kx. Now in for the y, I'm going to put this 9 value. And for the x, I'm going to put that negative 3. So notice 9 equals k times negative 3. Now to solve this, we're always just going to divide by this x value here. So we're going to divide both sides by negative 3. So we do that, and k is negative 3. So that's going backwards. That's all of this left side. Now once we have negative 3, we can put it over here and rewrite it. So let's do that. So now I write it as y equals negative 3x. And now they give me a value I want to put in. What do they say? They say y equals 15. So I'm going to take the y and I'm going to put in 15. Now they might tell me next time to put in for the x. It doesn't matter. Just do the one that they say. So 15 equals negative 3x. Well, how do we solve for x now? We can divide by negative 3. Divide by negative 3 and x equals negative 5, and that's our final answer. All right, so what about this one? Assume that y varies directly to x when y is 32 and x is 8. So we have our original problem. We're going to put the 32 in, and we're going to put the 8 in. Now, to find k, we're always going to just divide. So I divide, and k equals 4. Okay, then I rewrite it as y equals 4x. What number they want me to put in? Y equals 64. Again, I'm putting it in for y because that's the one that they tell me to. So 64 equals 4x. To solve for x, we're just going to divide by 4, and x equals 16. Trying again. So plugging in that negative 24, plugging in that negative 3, we get k equaling 8. Now notice this one. They want us to find y when x equals negative 2. So where am I putting this negative 2? I'm not putting it over here like all the other problems. I'm going to put it over here. You put it in for whichever one they tell you to. Now, how do I solve for y? I just multiply this. So sometimes they're going to be actually easier problems than what we did before. It just depends on what they tell us. They put the x in, they tell us to put the x in, so we do that. So 8 times negative 2 is negative 16, so that's my answer. And that's what I have for you today.